Previously, we used the DAQ board with the script editor, and we only perform an acquisition of the communication. But we did not perform any measurement on the signal captured. That's actually the aim of the scope feature, integrated into MP Manager. This feature is particularly useful for design and characterization test. It's totally possible to benefit from the DAQ feature of the CTS3, generate or perform the acquisition, and then use our signal processing algorithm in order to perform some LMA measurement or waveform measurement of a reader, for example. Previously, we performed a communication with a card. Now let's see what happened, or let's see what can be done with a reader directly, and let's use the scope feature in order to perform some waveform measurement. To do so, as previously with the script editor, I will indicate which channel will be used, the channel 1 in my case, with SMA connector, the 50 ohm termination. This time I will use an input range of 2 volts, and I will still indicate that the non-use BNC connector will be terminated with 50 ohms. The channel 2 will not be used. We will perform first an acquisition of 200 microseconds. It will be sufficient in order to catch the command sent by an external reader, and especially the wake up command in type A. To select this, I will indicate the trigger. As before, it will be an event. This event will be a card emulation from the CTS point of view, which is a type A wake up from the reader. Then we'll capture the raw signal. Let's click on configuration to hide the setting and keep only the viewer and perform a single acquisition. We have directly access to the wake up of the reader under test. I will add here setting a flag for the interpolation to smooth the signal. And then it could be interesting to perform some measurement, as I mentioned. To do so, I will add a type A PCD EMVCO 3.00 measurement. And I will also display the cursors that has been used in order to perform this measurement. As you can see, we have not only performed the acquisition thanks to the DAQ board, but we also perform now the measurement of the waveform characteristic of the type A modulation of the reader. Last but not the least, or even to go even further, we not only perform this measurement, display the results of the parameter, especially the timing parameter or T1, T2, T3, T4 parameter, which defines the envelope of the signal, but we also display if they are inside the range defined by EMVCO standard. Especially here, we not only have the value of those parameters, those measured parameters, but also the margin regarding the standard. In addition with this, right now I only did perform a single acquisition. But in fact, it's also possible to do this in a loop and see in real time the measurement, like with any external oscilloscope. But more than this, you have directly accessed in real time as well to the results here. If one of those parameters for the envelope type A modulation was out of the range, it will appear in red. For design and characterization, and especially for chipset architect working on chipset that will be used on reader or NFC reader, this feature can definitely be useful in order to be able to see in real time the impact of adjusting some register on the chipset, especially regarding the wave shapes modulation. Let's stop the capture. We did perform a type A waveform measurement. It's also possible to perform type B, type F, and V measurement for NFC enabled devices. To do so, I just need to select another kind of measurement and trigger. Let's remove the measurement here. Let's select a type B modulation, for example. Let's increase a little bit here the acquisition, or maybe 150, yeah, 1 millisecond will be more than enough for the wake up B command. And then here I will add a type B PCD measurement this time. When doing so, I start a new capture. We have the type B modulation which appear, and if I add here again a type B measurement, we have access to the measure for the falling and rising time, as well as the overshoot undershoot parameter after the falling and rising edge. It's also possible to display directly the cursor, zoom on the trace file, and as I mentioned earlier, you can do this in a loop. Let's stop the measurement. Note that it's also possible to store the trace as a screenshot, but also to save the trace into MP80 file format, which is usable with MP Waveform Viewer.